There is something out there that makes our sun look like a flickering candle. Something so violent, so incomprehensibly energetic, that the light it produces could be seen from the other side of the observable universe. And until very recently, we had no idea it could get this extreme. But now, after decades of searching, we have found it. And what it's telling us about the cosmos is rewriting the rulebook of physics itself. For as long as humans have looked up at the night sky, we have searched for meaning in the dark. We mapped the stars, charted the planets, and slowly began to understand that the universe is not the quiet, eternal backdrop it appears to be. It is violent, it is restless, and at its most extreme edges it harbors objects whose power defies every intuition we have ever developed. The question that has haunted astrophysicists for decades is this: where does it end? How far can nature push the limits of energy, gravity, and matter before physics itself breaks down? The answer, it turns out, is far further than anyone dared to imagine, and the object at the center of that answer has a name that barely does it justice. We are talking about a blazar, not just any blazar, but the most luminous, most energetic, most extraordinarily powerful single object ever identified in the known universe. A quasar with a jet pointed directly at Earth, driven by a black hole so massive, so ravenously hungry, that it is consuming the equivalent of several suns every single year. And in 2022 and 2023, new observations confirmed something that sent shockwaves through the astrophysics community. This object was producing gamma-ray photons at energies that, by all conventional models, should have been impossible. The universe had broken its own speed limit, and we had caught it in the act. To understand why this is so extraordinary, you need to understand what a blazar actually is, because calling it simply a black hole is like calling a thermonuclear explosion simply a fire. At the heart of almost every large galaxy in the universe sits a supermassive black hole. Most of them are dormant, lurking in the dark, consuming almost nothing. But a fraction of them are active, surrounded by swirling disks of superheated gas and dust known as accretion disks, and launching twin jets of plasma at nearly the speed of light in opposite directions perpendicular to that disk. When one of those jets happens to be aimed directly toward Earth, what we see is extraordinary. The jet becomes Doppler boosted, its radiation amplified by the geometry of its motion toward us, and we observe an object of almost supernatural brightness. That is a blazar, and the particular blazar at the center of this story is known as PKS 0735 plus 178. In October 2021, a neutrino detector buried deep beneath the Antarctic ice recorded an event, a single high-energy neutrino arriving from a direction in the sky corresponding to an otherwise unremarkable point in the constellation Orion. Neutrinos are some of the most elusive particles in the universe. They carry no charge, have nearly no mass, and interact with almost nothing, passing through entire planets as though they were empty space. For a neutrino to be detectable at all, it must have been born in an extraordinarily violent process. And this particular neutrino had an energy of around 170 tera-electron volts. It was not alone. Within days, the Fermi Gamma Ray Space Telescope and several ground-based observatories noticed an unusual flare in gamma rays coming from the same region. Then, optical telescopes caught a brightening. Then, X-ray satellites confirmed a spike in high-energy radiation. 4 completely different observatories detecting 4 completely different types of signals, all pointing to the same location in the sky, PKS 0735 plus 178. The evidence was overwhelming. This blazar was the source of one of the most energetic multi-messenger events ever recorded. Multi-messenger astronomy, the simultaneous detection of different types of signals from the same cosmic event, is one of the newest and most powerful tools in modern astrophysics. The idea is elegant. Just as a doctor uses multiple types of imaging to diagnose a patient, astronomers use multiple cosmic messengers to build a complete picture of what is happening at a source. Gravitational waves, neutrinos, gamma rays, X-rays, each one carries different information, and together they can reveal something no single instrument could ever tell you alone. And what PKS 0735 plus 178 was telling us through all of these messengers simultaneously was jaw-dropping. This blazar was not merely bright, it was operating at a level of power that challenged the very models we use to describe how jets form, how particles are accelerated, and how energy is transferred across cosmic scales. The black hole driving PKS 0735 plus 178 has a mass estimated at several billion times that of our Sun. Let that number breathe for a moment. 1 billion suns, compressed into a region of space smaller than our solar system, spinning and feeding with an appetite that can never be satisfied. As matter spirals into the accretion disk, the gravitational energy released is converted into radiation, with an efficiency that nuclear fusion, the process that powers every star in the sky, cannot begin to match. Nuclear fusion converts roughly 0.7% of mass into energy. The accretion process around a spinning black hole can convert up to 42%. The universe found the most efficient engine imaginable, and then pointed one of them directly at us. But the sheer brightness of this object is not even its most remarkable feature. What has genuinely stunned the physics community is the energy of the individual particles being accelerated inside its jet. The gamma rays detected from PKS 0735 plus 178 during its 2021 to 2022 flare reached energies in the hundreds of giga-electron volts. And, when combined with the neutrino detection, the implied proton energies inside the jet may be reaching into the peta-electron-volt range. This means that PKS 0735 plus 178, a blazar located roughly 7.7 billion light-years from Earth, may qualify as an extragalactic pivatron. That is a classification that, until recently, existed only in theoretical papers. The extreme energy of its particles, and the evidence that those particles are hadronic, meaning they involve protons, not just electrons, makes this object a candidate for one of the primary sources of the ultra-high energy cosmic rays that bombard our planet every single day. The trail of cosmic rays that scientists have been following for over a century may, at least in part, lead here. What makes this connection particularly compelling is the timing. For decades, the origin of the highest energy cosmic rays, those above the so-called GZK limit of around 50 exa-electron volts, remained one of the deepest unsolved problems in astrophysics. Cosmic rays at these extreme energies cannot travel indefinitely through space. They interact with the cosmic microwave background radiation, the ancient light left over from the Big Bang, and gradually lose energy over distances of hundreds of millions of light-years. This means that any cosmic ray hitting Earth at the very highest energies must have originated relatively nearby in cosmological terms, pointing us toward specific classes of objects in our cosmic neighborhood. And now, with the multi-messenger evidence from PKS 0735 plus 178, and a growing catalog of similar blazars identified by the IceCube Neutrino Observatory, the Pierre Auger Observatory in Argentina, and the Telescope Array in Utah, the picture is becoming sharper. Blazars, and more specifically, their relativistic jets, appear to be among the universe's premier factories for ultra-high-energy cosmic rays. The convergence of evidence across completely independent experiments is no longer a coincidence. It is a discovery. It is worth pausing here to appreciate just how staggering the engineering of nature is in a system like this. The jet of PKS 0735 plus 178 extends for hundreds of thousands of light years, longer than the entire diameter of our Milky Way galaxy. It is a continuous river of plasma, magnetic field, and accelerated particles, flowing outward at 99.99% the speed of light, for timescales longer than complex life has existed on Earth. Inside this jet, particles are bounced and reaccelerated through a process of relativistic shock acceleration, similar in principle to the Fermi mechanism operating inside supernova remnants, but operating at scales and energies orders of magnitude larger. The shock fronts within blazar jets are like cosmic particle accelerators stretching across the width of entire galaxies, and they have been running continuously for millions, possibly billions, of years. No human technology even approaches this. The Large Hadron Collider, the most powerful particle accelerator ever built by our civilization, reaches energies of around 13 tera-electron volts. The jet of a powerful blazar can push protons to energies 1,000,000 times beyond that. Nature, as always, is in a different league entirely, and yet PKS 0735 plus 178 is not simply a curiosity at the edge of the observable universe. It is a template. Since its discovery as a multi-messenger source, astronomers have been looking at other blazars with fresh eyes, and what they are finding is transforming our understanding of the high-energy universe. In 2023, the IceCube collaboration published a landmark result, a statistically significant correlation between high-energy neutrino events and the positions of active galactic nuclei, particularly blazars, across the sky. This was not a detection of a single source, but a population-level signal, suggesting that the class of objects as a whole is responsible for a significant fraction of the high-energy neutrino background that IceCube has been accumulating for over a decade. In other words, the most powerful objects in the universe are not rare exceptions. They are a fundamental feature of how the cosmos processes and redistributes energy across cosmic time. What this also means is that our view of the universe's energy budget is fundamentally changing. For most of modern astrophysics, visible light and radio waves provided our primary windows onto the cosmos. But the universe, it turns out, does much of its most important work in regimes we can barely detect. In gamma rays above the atmosphere, in neutrinos passing through the Earth, in cosmic rays that have been traveling for millions of years before slamming into our upper atmosphere. The universe is not the place our eyes have described to us. It is wilder, more violent, more astonishingly energetic, and the most powerful object we have ever found is not some ancient relic of the early cosmos. It is still active, still feeding, still launching its jet across intergalactic space, still accelerating particles to energies that our most sophisticated theories struggle to fully explain. The discovery of PKS 0735 plus 178 as the most powerful multi-messenger source ever detected, the ongoing confirmation that blazars are extragalactic pivotrons, and the emerging picture of the high-energy universe built from neutrinos, gamma rays, and cosmic rays simultaneously, all of this is happening right now, in real time. We are living through a revolution in astrophysics as profound as the one triggered by the first radio telescopes, or the first X-ray satellites. And the deeper we look, the more power we find hiding in the dark. There is something deeply humbling about this moment in science. For over a century, we detected cosmic rays raining down on our planet and had no idea where they came from. We built detectors on mountaintops and buried them beneath the ice of Antarctica. We launched satellites and constructed arrays spanning hundreds of square kilometers, And piece by piece, cosmic messenger by cosmic messenger, we traced those particles back across billions of light years to an object whose power is so extreme it strains the very language we use to describe it. A black hole consuming suns, launching a jet the size of a galaxy, and accelerating particles to energies 1,000,000 times beyond anything we can achieve on Earth, and doing it for longer than the dinosaurs existed. The question that should stay with you is not simply what this object is. The question is what it means that nature can do this at all. What does it mean for a universe that contains such extremes? What other objects are out there, just beyond the edge of our detection, pushing these limits even further? And if the most powerful object we have ever found is still active, still growing, still burning, what does that tell us about where the universe is heading and how much power it still has left to reveal? We found the most powerful object in the universe. But the deeper truth is this: we suspect it may not be the most powerful one that exists. And that thought, that magnificent, terrifying, irresistible thought, is why we keep looking up. If this video made the universe feel bigger and stranger than it did 10 minutes ago, then it did exactly what it was supposed to do. Share it with someone who still thinks space is empty and quiet. Leave a comment telling me what you think the universe's ultimate limit truly is, because I genuinely want to know. And if you want to keep going down this rabbit hole together, the subscribe button is right there. The cosmos is not finished surprising us, not even close.